Let us solve a question on CES production function. The question is, suppose you have the following production function, that is Q is equal to 0.5 k to the power 0.5 plus 0.5 L to the power 0.5 whole square, where L and K are the units of labor and capital and Q denotes the output. We have to calculate the rate of technical substitution, and if wage rate is $20 and the rental rate of capital is $100, we have to calculate the minimum cost of producing 54 units of production, and last part tells us to calculate the elasticity of substitution. Okay, so we have this constant elasticity substitution production function. I have explained about this production function in earlier videos. You can check out those very videos also. Okay, so first thing is, first we need to find out the marginal rate of technical substitution. Okay, so MRTS, so rather TS between labor and capital, or let's write it simply, marginal rate of technical substitution between capital and labor is equal to the marginal product of labor upon marginal product of capital. Okay, so what is marginal product of labor? It is simply the derivative of production function with respect to labor first, divided by marginal product of capital means the derivative of production function with respect to capital. Okay, which is equal to, that means MRTS will be equal to, now dq upon dl, this is our production function taking derivative with respect to L. So we have here, this 2 becomes coefficient, we have 2, then we have 0.5 k to the power 0.5 plus 0.5. We are using the power function rule first, L to the power 0.5. So 2 becomes coefficient and 2 is subtracted by 1, so it will remain 1. And we internally are using chain rule, we differentiate with respect to L this time. Okay, so the derivative of L to the power 0.5 will be equal to, we have first 0.5 times derivative of L to the power 0.5 is 0.5 L to the power, using again power function rule, exponent will be subtracted by 1, so we will get minus 0.5. Okay, if you are getting confused, let me write it in bold letters, bade harfo san. That is, we have this very function Q is equal to 0.5 k to the power 0.5 plus 0.5 L to the power 0.5 whole square. Okay, so what I have done here, I have taken the partial derivative of production function with respect to L. That means first we apply the power function rule, this 2 becomes coefficient. Okay, 2, then we have 0.5 k to the power 0.5 plus 0.5 L to the power 0.5, and this exponent is subtracted by 1 by power function rule. Then we internally differentiate, or using chain rule, we take the derivative again with respect to L. So L is in this term, we write 0.5 L to the power 0.5. Okay, when we take its derivative, it comes out to be minus 0.5 raised power minus 0.5. Okay, divide by, using the same method, you will get for mpk dq upon dk will come out to be, that will come out to be 2 0.5 k to the power 0.5 plus 0.5 L to the power 0.5 times 0.5 times 0.5 k to the power minus 0.5. Okay, this is dq upon dk. You can check it out, no problem. So let us see here, do some cancellation. This gets cancelled, this whole term gets cancelled with this 0.5, 0.5, 0.5, 0.5 gets cancelled. So MRTS comes out to be L to the power 0.5 k to the power 0.5. If I transpose k to the power 0.5 to numerator and this L to the power 0.5 to denominator, exponent sign will get changed, so we will get k to the power 0.5 upon L to the power 0.5. I can write it in this fashion, that is K upon L raised power 0.5. Okay, so let's write in place of 0.5 to make more sense. We can write it also 1 upon 2. Okay, so this is our marginal rate of substitution between capital and labor. And this is the first part. Second part tells us to calculate the minimum cost of producing 54 units of production given the wage rate is $20 and rental rate of capital is $100. That means what we are being told, to minimize, let me write it here, minimize cost which is equal to wage rate into units of labor plus rental rate of capital times units of capital subject to the production constraint. That means we have this 0.5 k to the power 0.5 plus 0.5 L to the power 0.5 whole square should be equal to, so we need to produce 54 units. Okay, so the question reduces to minimize cost subject to the given production constraint. And what is here W is being given 20, so I can write it in this fashion 20L plus 100K. This is our function. So we have the cost minimization problem. We can use either the Lagrange method in finding the optimal quantities of labor and capital, or we use the tangency condition. Let's use the tangency condition for the sake of simplicity. That means first order condition for optimization requires that our marginal rate of substitution, technical substitution, should be equal to price of labor upon price of capital. MRTS we calculated, it came out to be K upon L raised power 1 upon 2 price of labor, which is being denoted by wage rate. Okay, this also denotes the price of labor. This is our price of capital. Okay, so price of labor is being given us as $20. So 20 upon 100. So 2 and 2 gets cancelled. We get 1 upon 5, I guess. Okay, so we will get K upon L will be equal to, so here it reduces to 1 upon 5. If I transpose this exponent, it will become square, so we get 1 upon 5 5s are 25. Okay, so I get 25. That means L will be equal to 25K. Okay, now we simply plug the value of L into this function to get the value of K first. So we have 0.5 K to the power 0.5 plus 0.5. In place of L we have this 25 K to the power 0.5 whole square should be equal to 54. So we have 0.5 K to the power 0.5 plus 0.5. So 25 raised power 0.5, so under root 25 is 5. Then we have K to the power 0.5, K to the power 0.5 whole square. I hope I am doing the calculation right. So we can do one thing now. What is a 5 into 0.5? So we have 5 upon 10 into 5. So this is 5 ones are 5 twos are, this comes out to be 2.5. Okay, so we get 2.5. This comes out to be 2.5. Then we have 0.5. This comes out to be 3. So we get 3 K to the power 0.5 square uh, is equal to 54. Okay, now in calculation kunjai galat. So it is 3 3s are 9. 0.5 and 2 it will get cancelled, so we will get 54, or k will be equal to 54 upon 9. So now ge arda arda ge kshetra 9 5s are 45. No, 9 5s are 9 6s are 54. So we will get 6. That means units of capital came out to be 6. To find the units of labor, simply plug k is equal to 6 here. That means L will be equal to 25 times 6. This comes out to be 6 5s are 30, 6 2s are 12, 13 14 15. That means units of labor will be equal to 150. Now the minimum cost of producing 54 units of labor, so just plug the value of L and K into this cost function, that is, which is our objective function. So let's write it here, or let's write it here. So our cost will be equal to 20 times units of labor, which is 150, plus 100 times units of capital, which is 6. So let us see if I can do the calculation right or be payeth parishani. So as go is 0 gonathi ak tag is 2 5s are 10 go 3 imte 2 1s are 2 tag 3 kya dra 3 20L 100 times 6 k ko ta dra share. So let us see, 100 into 6 is 600. So we get 3600 as the minimum cost of producing 54 units of output, given the wage rate is equal to $20 and rental rate of capital is equal to $100. Okay. What we have done, we have simply used the first order condition. That means given we have this we have units of labor here, capital here, we have this we want to minimize cost. Okay, so we are being given the ISO count and we want to produce at that ISO count at the minimum possible cost, and it will happen when we produce, when the ISO count and that is production ISO count and our cost functions are tangent to each other. Okay, this is being told by MRTS is equal to price of the ratio of the inputs. Okay, so this was second part. I hope I have done the calculation right. Third part is to find out the elasticity of substitution. Okay, so elasticity of substitution, to derive the elasticity of substitution. Okay, let us denote capital labor ratio, that is K upon L. Let us say we denote it by Y, and price ratio, that is Px upon Py, price of labor upon price of capital, let's denote it by P, capital P. Okay, then elasticity of substitution is simply the derivative of capital labor ratio with respect to dy upon dp. That means the derivative of capital labor ratio with respect to the input price ratio times P upon Y. Okay, this gives us the elasticity of substitution. So what we have written here, PL upon PK. So our K upon L, here we got our MRTS came out to be K upon L square. Okay, and it should be equal to the ratio of the prices. That means PL upon PK. Okay, if I transpose it here, that means K upon L should be equal to PL upon PK square. Okay, it is 1 upon 2 here. Our MRTS came out to be, am I making the sense here or not? Let me repeat it again for the sake of convenience. To find this very stuff, okay, we know that first order condition requires, and let me write it here, that our MRTS should be equal to the ratio of input price ratio, that means price of labor into price of capital. MRTS came out to be K upon L raised power 1 upon 2 should be equal to PL upon PK, which can be written as K upon L is equal to, transposing this, it will become square PL upon PK whole square. Okay, that reduces K upon L, we denoted by Y, should be equal to this. So this is our Y, this is our P, so this should be equal to P square here. Okay, so Y is equal to P square, capital P square here. So Y is equal to P square. Elasticity of substitution will be equal to dy upon dp. So dy upon dp will be equal to twice p here. Okay, so in place of this I can write twice p times p upon y is equal to p square, which gives us substitution will be equal to twice p square divided by p square, square square cancels. So elasticity of substitution came out to be 2. Okay, so we got elasticity of substitution equal to 2. And how do we interpret it? It simply tells us a 1% increase in the input price ratio causes the ratio of the purchase of the uh, input, that is capital, to labor, that is labor, to increase by 2%. Okay, simply a 1% increase in the input price ratio causes the ratio of the capital labor ratio to increase by 2%. Okay, so I know it got messy, but kya kara